Okay. Hi there. Welcome to Engage New York Module 4, Lesson 20. This is concept development. Now, as we begin Lesson 20, I want you to realize that in third grade, you interpret multiplication as equal groups. And in fourth grade, you begin understanding like multiplication as a comparison. So once again, in fifth grade, what we do is we take the idea of equal groups, we take the idea of comparison, and now we're extending our understanding of multiplication into scaling. And scaling is a really big concept, a priority standard, if you will, in fifth grade. So students compare the product of to the size of one factor. For instance, like it is twice as large. um, it sets the stage for students to reason about the size of products when quantities are being multiplied by one, or numbers larger than one, or even numbers smaller than one. So it also goes back and relates to equivalent fractions and helping you to interpret equivalent fractions. So where we're going and how this relates is by resizing or scaling, and that's a big factor and a big idea in fifth grade math. So we spend a lot of time on fractions and multiplication. All right, so let's go ahead and begin with this problem. Now, in our previous lesson, in lesson 19, we were converting smaller units to larger units, right? But look at this problem that we're starting with. We're going from yards to feet, right? So which units are larger, yards or feet? Yards are bigger, right? So when we compare this problem with the conversions that we did on the previous lesson, what do you notice about the units? Well, this problem is starting with larger units and converting to smaller ones. Our previous lesson, every conversion we did was smaller units to larger units. So this is a large to small. Remember, we were writing, I'm going to say larger to smaller, right? So let's begin. Let's just start off by drawing a tape diagram of 4 1/3. 4 1/3 yards. Okay, so we want to name 4 1/3 yards using feet. That's what we're going to rename this, right? So this is 4 1/3 yards total. So let's partition the bar into 4 equal units to represent the 4 whole yards and one smaller unit to represent the 1/3 of a yard. Okay, so here let's section off our 1/3. Okay, and then we have 4 yards here. So here's 1 yard, 1 yard, 1 yard, 1 yard. Okay. So 4 1/3 yards is the same as 4 1/3 times 1 yard, right? All right. How many feet are in a yard? Well, there's 3 feet in 1 yard, right? So you could simply throw those 3 feet in there and then take 1/3 of a yard. I'm 1/3, yeah, 1/3 of a yard here, right? Or 1/3 of a foot. So let's show 1 yard equals 3 feet. Right? This is 3 feet. This is 3 feet. This is 3 feet. This is 3 feet. That's 1/3 of a foot, right? All right. So let's write a new expression right here. Let's say 4 1/3 times, now I'm trying to rename, right? 3 feet. Before we multiply, let's express 4 1/3 as an improper fraction, because before you can multiply, you cannot multiply an improper fraction like this, right? So let's go ahead. How many thirds are in one whole? There are 3/3, right? So let's throw this in. Here we go. Here is 3 times 4 is 12 plus 1 is 12/3, right? Let's see if you can do that really quick and see how you do. Come back and check your work. What did you do? I mean, I could talk you through this and say, like, how many thirds are in one whole? There are 3/3. So how many thirds are in 4 wholes? 12/3. How many thirds are in 4 1/3? There are 13/3. Or you can go use what you've learned about multiplying and changing an improper fraction into an improper fraction. I mean, a mixed number into an improper fraction. So 3 times 4 is 12 plus 1 is 13. 13/3 times 3 feet. Okay. Now, this is our new sentence. This is our new equation, right? So multiply that out, and what do we get? So we know we can cross cancel those 3's, right? And we end up with 13 feet. Now, let's look at the idea that what we know right here. So let's just write down what we know. We know that 3 feet is equal to 1 yard, right? Now, we were going from, in our previous lesson, we were going from 3 feet, we were converting from a smaller unit to a larger unit, right? And then when we were doing that, we were dividing and creating 1 foot is equal to 1/3 of a yard, right? Well, now we are going from, so this in this direction, going from smaller unit to larger unit. But now we're going from, let's just keep it in the same format. 3 feet is equal to 1 yard, right? But now we're going from this direction to this direction. We're going the opposite. Now, if I try to use that same strategy of dividing, well, guess what? 1 yard is still equal to 3 feet. Sorry. 1 yard is still equal to 3 feet. So the difference when we were going from smaller unit, smaller to bigger, we were using that strategy to get a portion of that foot in order to rename those units, right? Well, when we're going from larger unit to smaller unit, you don't have to divide at all. All you have to do is take what you know. 1 yard is equal to 3 feet. 1 yard is equal to 3 feet. You don't have to do this right here. You don't have to find the fraction of that piece, the fraction of the smaller unit, or sorry, the fraction of the larger unit. Instead, you just use what you know. 1 yard is equal to 3 feet. So our answer is 13 feet. So I wanted to point this out just so you know you're not getting confused. So when you're going from smaller unit to bigger unit, 1 foot is equal to 1/3 of a yard. But when you're going from bigger to smaller, you just use what you know. You don't have to convert anything. You don't have to rename those units in that way. you can simply use the numbers. It doesn't matter, because if you were to divide out, you're going to end up with the same thing. All right, let's try it again. Let's go from 2 and 1/4 foot. So we are using bigger measurements now, 2 and 1/4 foot, and we're going to put that into inches. So let's write down, what do we know? We know that there are 12 inches in 1 foot, right? Now I'm using the same format as that we used in the previous lesson, but now we're going from here to here, right? Instead of going inches to feet, I know that there in 1 foot there are 12 inches. Okay, so let's go back with the same format. 2 and 1/4 foot is equal to, well, we don't know how many inches. So we're going to go 2 and 1/4 foot, 2 and 1/4, 2 and 1/4 copies of 1 foot. So I'm using that same structure that we used before. 2 and 1/4 copies of 1 foot. So we know we're going to change our inches, our feet into inches, right? And we know there are 12 inches in 1 foot. So 2 and 1/4 times 12, and don't forget to change your units. We're now going into inches, right? And that's what we need to have our answer in. So I'm trading out that 1 foot for the 12 inches. But before we can multiply, we have to change this to an improper fraction, right? Because you can't multiply that mixed number the way it is. 4 times 2 is 8. 8 plus 1 is 9. 9/4 times 12 inches gives us, I'm going to do a little cross canceling, 27 inches. It's actually a little bit easier than doing what we did before, right? Okay, so how about, do you want to do gallons to 3.5 gallons to so many quarts? Let's do one more problem. We have some room here. So let's go 3.5 gallons is equal to how many quarts? Well, first, what do you know? It's always good to just kind of stop and regroup. What do I know? How many quarts are in 1 gallon? There are 4 quarts in 1 gallon, right? So now we're going up here. We're going from larger units to smaller units. Now, if I try to divide this out, guess what? I'd end up with 1 gallon equals 4 quarts. So we're using the 4 quarts in our conversion. So let's come over here. 3.5 gallons is equal to how many quarts? That's what we're trying to solve. So if I have 3.5 copies of 1 gallon, now I have 3.5 times, what number am I going to use now? I'm going to use the 4 quarts, right? Because I need my answer in quarts. So I have 4 quarts now, right? But before you can go any farther, we have an issue we need to solve. We need to change that to an improper fraction, right? Okay, so 2 times 3 is 6. 6 plus 1 is 7. 7 halves times 4 quarts. I'm going to cross cancel a little bit, and we're going to end up with 14 quarts. All right, is this coming a little bit easier? How about hours to minutes? Right? We're going to be using all of that. Okay, turn the page. Or if you have room, keep going. But we're going to move now. Okay, we're going to switch gears and we're going to go back to that converting smaller to larger. So we're going to go back to using the fraction. So smaller. It's not very good. I'm going to write this a little bit better. Smaller to larger. Use the fraction. But larger to smaller, don't use a fraction. Use the whole number. Okay, so we are going from feet to yards. So which units are larger, feet or yards? Yards. Okay, compare this problem with the ones we just solved. What's the difference? This one gives us the measurement in smaller units and wants the amount in larger units, right? So this one goes from smaller units to larger units, such as the ones we did in the previous lesson. Okay, so what fraction of 1 yard is 1 foot? So let's go back to what do we know? We know that there are 3 feet in 1 yard, right? So what do we do? 1 foot is equal to 1/3 of a yard. Okay? That's what we know. That's what we've been practicing with. Smaller units, smaller to larger. Okay, so let's begin solving. 11 feet is equal to how many yards? That's what we're trying to solve. So we know we have 11 copies of 1 foot. That's what we're starting with. 11 copies of 1 foot. But now we're going to take 11 copies and we're going to change our feet into yards because that's what we need our answer into. So we're going to say we're going to change that to 1/3 of a yard, right? So 11 times 1 is 11 over 3. So 11 thirds of a yard, but we can't leave it like that in an improper fraction. So 3 goes into 11 3 times, right? So how many are left over? 2/3 of a yard is left over. All right. How did you do on that one? This should be getting a little bit easier. Okay. Here we go again. So now let's go 3 1/3 quarts is equal to how many gallons? All right. Do you want to draw a tape diagram? We can. So we know how many quarts are in a gallon. One quart, 1 quart, 1 quart, 1 quart, right? And then we have this little 1/3 of a quart here. Are you with me? And we're trying to figure out how many gallons this equals, right? So let's go. What do we know? We know that there are 4 quarts in 1 gallon, right? So 1 quart is equal to 1/4 of a gallon, right? Okay, so now we have our number that we're going to convert to. We're going to rename those units. We're going to rename our units from quarts to gallons. So we have our number that we're going to work with. So we have 3 1/3 quart. is equal to how many gallons. Notice I try to follow the same structure each time. So 3 1/3 copies of 1 quart. So I take my 1 quart and I'm going to exchange my 1 quart for 1 1/4 of a gallon right here. This is where that conversion or that renaming takes place. So now we're working in gallons. All right, but now we can't multiply with a mixed number. So we need to change it to what? An improper fraction. So 3 times 3 is 9 plus 1 is 10. 10/3 times 1/4 of a gallon. I keep doing that so I don't forget what I'm working with. So it's not necessary really to cross cancel here. We can do it down here. We end up with 10/12. 10/12 ends up with what? 2 times 5 is 10. 2 times 6 is 12. Cancel out our 2's and those become 1. It becomes 5/6 of a gallon. All right. Are you ready to take on our last problem? Okay, now this is where that two-step problem comes in with. So, this container, so this is the more savvy, more advanced thinker right here, is taking it. A container can hold 4.5 pints of water. How many cups of water can 2 containers hold? So this problem takes on a whole new ball of wax here because it's going to be a two-step problem. That's all. Not that big of a deal. But you definitely don't want to just look at the problem and give up. So, how do you solve this problem? What can you see? Well, it's a two-step problem. I first have to convert 4.5 pints to cups, right? I have to go from pints to cups. And then I have to double it and go 2 containers. So when you think about that, you go, oh, okay, I can do that, right? So let's just start off. Let's just draw a picture. Here's a tape diagram of, this is 4.5 pints right here. How many cups? So I want to know how many cups are in here. So here is my half. I'm going to mark off my half. Then I'm going to, so how many pints? So let's go back and start thinking about what we know. We know there are 2 cups in 1 pint, right? So 1 cup is equal to a half a pint, right? So now let's go ahead. This is going to be our renaming, right? So let's go up here. 4.5 pints is equal to how many cups, right? So now I have 4.5 copies times 2 cups because we have to double it. We're going to times 2. All right. Think about this for 1 second. I'm trying to decide, should I just go 1 cup and then multiply by 2, or should I just jump right in and double it? That's what I'm thinking about right now. Okay, I don't like where we're going with this. I kind of lost sight of, we're going from pints to cups. Pints are greater than cups. So we're actually going in this direction. Okay, so we don't need to break this up like this. Remember, if we were actually going from greater to smaller, if we divided it out, it would still be 1 pint is equal to 2 cups. Okay, I lost sight of where I was going there for a second. So sorry. Okay, but I'm glad I caught it. Okay, so now let's go back to what we know. Let's go back. We did our fix up strategy. We're heading in the wrong direction, but we turn it around. So 2 cups is equal to 1 pint, and we're going from pints to cups. Pints are greater than cups. So we're going from a larger unit to a smaller unit. So 1 pint is equal to 2 cups. This is our conversion, okay? We're going to cups. We're going to cups. We're going to cups. Okay, so 4.5 pints is equal to how many cups? Well, 4.5 copies of 2 cups right here. 2 cups. We're getting that from here. Just the way we're supposed to. Now, we can't multiply yet because we have a mixed number and we have to change it to an improper fraction. So 2 times 4 is 8. 8 plus 1 is 9 halves times 2 cups. I can go ahead and cross cancel. It ends up being 9 cups. Now, how many cups of water can 2 containers hold? So a container can hold 4.5 pints of water. So in 1 container, it's going to hold 9 cups. But in 2 containers, it's going to be 9 cups times 2 containers. Here, let me write cups underneath. Nine cups times 2 containers ends up being 18 cups. So the answer is 2 containers can hold 18 cups. All right. Sorry, I started steering us in the wrong direction there, but we flipped it around and I stopped to think about what I was doing for a second. And, that's what you do in math. You're always stopping and going, wait a minute. I'm going from pints to cups. A container can hold 4.5 pints of water. How many cups are in each? Then we had to figure out how many would just be in 2 containers, right? All right, so this will do it for our concept development or a lecture. You're going to meet me back here after you have completed the problem set to check your work. That way you can make sure you are heading in that right direction, and if you need to flip it around, you need to flip your direction around. That's where you use those fix up strategies and go, wait a minute, what was I doing here? Let me fix this. So we have exactly what we were doing. We're doing feet to inches, pints to quarts, hours to minutes, feet to yards. All right, then on the back, let's look at our word problems. Don't just give up on the word problems. Solve the word problems. All right. So 3 dump trucks. If you don't ever try it on your own without looking at the video ahead of time, you're not going to have that security of knowing when you go to take a test that you know how to actually attack the problem. So 3 dump trucks are carrying topsoil to a construction site. Truck A carries 3,545 pounds. Truck B carries 1,758 pounds, and Truck C carries 3,697 pounds. How many tons of topsoil are there in 3 trucks carrying all together? Now, one thing you should know are there are 2,000 pounds in 1 ton. Okay, that's going to be that little nugget of knowledge that you're going to need. Then we have Melissa buys 3 3/4 gallons of iced tea. Danita buys 7 quarts more than Melissa. How much tea do they buy all together? So might have to do some adding right there. All right, in order to get, like this is going to be 2-step. You're going to need to solve how many quarts they have before you can start to convert it into gallons, right? Okay, then Marvin buys a hose that is 27 3/4 feet long. He already owns a hose at home that is 2/3 the length of the new hose. How many total yards of hose does Marvin have now? So, what is 2/3 of 27 3/4 before you can start your conversion? Okay, so this is actually more of a 3-step problem. 1, 2, 3 before you can, I think, actually solve the problem. So take it 1 step at a time. Step 1, step 2, step 3. Know that you should probably have 3 steps in this bottom problem. If you don't, then try to figure out what your salt. Remember, how many total yards of hose? So we're going from feet to yards, right? All right. Before you go back and check the problem set debrief, try it. See if you can come up with an answer. Then go back to the problem set debrief to check your work. All right. Good luck.